Okay, let's go ahead and get started. Today we're going to review 8.4, hypothesis testing. Don't forget on your magic formula sheet that one part where it talks about degrees of freedom for two samples. It's the smaller n minus 1. And then today we're going to go over 9.1/9.5 confidence intervals for two sample proportions and means. You have Connect Math 8.1/8.4 due tonight, and also, lab part 6. You guys can turn it in late still today for full credit. Forgot you guys are one behind me. Thursday, you have Connect Math 8.3 due, and then next Tuesday, 9.1/9.5 due, and also lab 7. And then next Thursday, Connect Math 9.3. Your exam's going to be on November 26th, which is the Tuesday before Thanksgiving, covering chapter 7 through 9. If you want to take it the Thursday before, you can take it at 5 o'clock or 7:30 the Thursday before, if you want. Okay. So as a reminder, we have two different things we've got going on. We have our unusual level requirement. This is all about step 2, right? What's our alpha? What's our critical value? Right? We use alpha in our t-table to look up and figure out what the critical value is. So that's kind of what we're measuring against, what we consider unusual or not. Then we have our sample. Our sample, we take a sample and we figure out what our test stat is, and we can find our p-value from there if we wanted to. So these are the things for our sample. We compare them. We can either do what we traditionally have been doing, which is comparing the test stat to the critical value, comparing z-scores to see which one's further away from the mean. Because the further away from the mean you are, the more unusual you are. Or we can compare percents of the tail. P-value against the alpha. Those are probabilities, right? So what's our general guideline for unusual? 5%. 5% or less. That's typically our alpha. If you're less than that, if your probability is less than 5%, then you are unusual. Remember, the whole point of the test, hypothesis test, you guys focus. The whole point of a hypothesis test is to see if your sample is unusual or not. If your sample is unusual, then we'd say that your population is probably different from the mean. The null hypothesis says that your population is the same as everybody else's populations. In other words, like my deck of cards, the population of cards in my deck is the same as everybody else's deck. Right? So how many red decks are there typically in a what percentage of cards are red in a deck typically? 50%. So the null hypothesis would say that my deck has 50% red cards. And then we took a sample, right? And we got like 6 or 7 red cards in a row. Is that unusual? Yes. So then we'd say that, well, because our sample was so unusual, that my deck, the population of cards in my deck, is probably not the same as everybody else's deck. And we would reject the null hypothesis. Because the null hypothesis says that my deck is the same as everybody else's deck. Makes sense? My population is the same as everybody else's population. So we would, remember, if you get something unusual in your sample, then you say that you reject the null hypothesis. Because you're saying that yours is somehow different than everybody else's. Your population. People who take your drug, your smart drug, they're going to score higher. Or people who take your special blood lowering medicine, blood pressure lowering medicine, right? They're going to be lower or something like that. So again, if you get something unusual, you reject the null hypothesis and say that yours isn't the same as everybody else's. So that's what you can either compare p-values, probabilities, right? Less than 5%, or alpha could be, we can change alpha to be 10% or 1%. Typically it's 5% if we don't indicate what it is. Or you can compare critical values, z-scores, critical values to the test stat. Here are our 5 steps, which, no one going to read those for us?
Hypothesis test traditional. Step 1, state the hypothesis and identify the claim. Step 2, find the critical value. Step 3, find the test value. Step 4, make the decision, see which z-score is farther from the center. Step 5, summarize the results.
Right. And don't forget to draw a picture here. Draw a picture. That'll be worth 2 points on your exam, so make sure you do that every time. Step 1, figure out your hypothesis is. Write your claim using greater than, less than, not equal to, or equal to. Write H naught. H naught is always, always, always that P or mu equals. You guys do a little better. Null hypothesis is always that mu or P equals. No difference. Null. Null difference. If your claim is equals, then H1 is your claim. If your claim is not equals, then you need to make H1 your claim. Good? Again, the only times that your claim is H naught is when your claim is equals. Make sense? The other thing is, the only time that your test is two-tailed is when your claim is equals or not equals. When your claim is equals or not equals, then you have a two-tailed test. If your claim is less than or greater than, then you have a one-tailed test. Less than, one-tailed left-tailed, greater than, one-tailed right-tailed. Okay, so that should be, you guys should be good with that part. Step 2, find the critical value. When do I use a z-table? A z-distribution?
When it's the proportion.
When it's a, what's the mnemonic? Easy peasy. Easy peasy. Proportion, use a z-table. When do I use a t-table? Mean Mr. T. Yep, when you have a mean, you use a t-distribution. Make sense? Everybody good? They are on the same sheet of paper. Alright, so all of these are t-distributions. The very last row only is a z-distribution. If you want to write next to that z-table or z-distribution, that's totally fine. Okay, so remember, means, mean Mr. T, use the t-distribution. Then degrees of freedom matters. Z-distribution, doesn't matter what your n or your degrees of freedom is, you just use this bottom one. The n comes into your standard deviation, and it affects that. Step 3, find your test stat. How far is your sample from what you expected to get? From your claim, from your mu naught or your p naught. And then divide by what a standard deviation is. So it depends. For proportion, you'd be p hat minus p divided by square root of pq over n. Make sure when you write this in your notes that that square root includes the n. It's the whole thing is square rooted. But some of you guys got lazy and only square rooted the pq, and then it screwed you up when you try to do it later. And then the test stat, your x bar minus your mu divided by s over square root of n. Find this first. People, if you don't do that, a lot of people will divide by both these and they'll get a completely wrong answer. So especially this one, find your top, find your bottom, and then divide them. How do you know which one's the sample and which one's the population one? This is the one in your claim. This is the one they may state. Like the average number of internet user is online for 36 hours a month. This is what what your sample is. So you find the word sample, or you find the word selected, or you find the word surveyed. Those are all kind of words that mean sample. That's where you're going to find your x bar or your p hat. Right, so remember, p hat is your sample proportion, x bar is your sample mean. Okay, so when you find your test stat, you'll find it and then you'll put it into your picture. You can also use these, right? So it's totally fine. You write out your formula with the numbers in it. 24.3 minus 26.0 divided by 6 over square root of 32, whatever. And then you can use your calculator to figure out what that number actually is. Right? Stat test t-test is for your t distribution for your means. Stat test 1 prop z-test, 1 proportion z-test, that would be the one for proportions. And please note, they don't ask you what alpha is because they don't care about alpha. Your test stat is all about your sample. Step 3 is all about your sample. Step 2 is all about alpha and your level of unusualness. Step 3 is all about your sample. They have nothing to do with each other. So if you wanted to use this to calculate it, you can totally do that, just write the number in. I won't know the difference. Maybe let me know that you did it if you want, just in case. Sometimes you get something weird, like something a little bit different than everybody else gets. That will help me explain to me why. Step 4, figure out if you reject H naught. So in other words, what we've been doing is we've been having this area, right? This is our critical value. And we figure out where our test stat is. Would I reject my test stat here? Or not? Would I reject H naught?
Yes.
Why? Is it unusual or not? It's unusual. It's way out there. Do you guys see that? It's in the shaded area. That's what we consider unusual. Anything in here is close enough to the mean that we'd say, okay, H naught might be right, because H naught says I'm right here in the middle. I'm right where the mean is. Your population is the same as everybody else's. It's right in the middle, or close enough. If you're way out there, then you'd say, oh, no, you're different. We're going to reject H naught. You're not the same as everybody else's. You're way over there. All right, so again, remember, we're going to reject if either our test stat is bigger, or if we compare probabilities, if the p-value is smaller than alpha, less than 5%, right? Probability is less than 5%, your p-value. So in other words, if this probability of getting your sample is really unlikely, less than alpha, then it's unusual, and we would reject the null hypothesis. Let's make a better picture, right? So if we're anywhere over here, he might be guilty. Do you guys see that? That might be like 7, 8%. You might be different, but we don't have enough evidence to say that you are. Everybody kind of follow that? So here, looks like it could be different. Looks like my mean is not the same as this. Do you see how this looks like it's not the same as that? But I don't have enough evidence. If I'm over here, this is my requirement. It has to be that much different. Have to be over in this area over here. So here, this is where we definitely would say they're guilty. We definitely know for sure it's different. Over here, we do not have enough evidence anywhere in here. So we can't for sure say that we would reject something or support something. Only over here can we reject or support something for sure. Over here, we don't have enough evidence to reject or support. So that leads us into step 5. Step 5, if we didn't reject H naught, step 4 is all about H naught. Make sure that you guys are really clear. Step 4, all about H naught. You either reject H naught or you don't reject H naught. You either reject H naught or you fail to reject H naught. Step 5 is all about your claim. All about your claim. Carly, go ahead.
So usually when it's like one-tailed, it's always do not reject. And
No.
No?
If it's one-tailed, if one-tailed, you could totally reject if you're over here.
Oh, okay.
If it's one-tailed, doesn't matter. If you're in this, and if you're in the shaded area, you're going to reject. If you're not in the shaded area, you're not going to reject. Don't go off of whatever random samples, problems we happen to have in class.
Okay.
You could absolutely reject if it's one-tailed. You can absolutely reject if it's two-tailed, or not reject in either case. It depends upon where your test stat came in at. So here, if I'm over here, my test stat was here, I would reject H naught. Everybody follow that? I would have enough evidence to do something. In this case, my claim must be right-tailed. Because it's right-tailed, my claim must be greater than. So here, I would not have enough evidence to support my claim. So my claim is clear that I'm greater than something. I wouldn't reject my claim. I would not have enough evidence to support my claim. Does everybody see where I'm going with this? So because it's right-tailed, it has to be, my claim must have been that I'm greater than. So only time you're greater than, anytime you're one-tailed, that has to be your claim. So my claim is that my mean is greater than everybody else's mean. I don't have enough evidence to prove that. So I would say not enough evidence. Everybody got the not enough evidence part? To support my claim that my mean is greater than everybody else's mean. I would not reject my claim, because my claim might be true. I just don't have enough evidence to support it. It's not the same thing. Rejecting a claim is much stronger than not supporting a claim. Does everyone get a handle on that one? Rejecting and saying, no, you're definitely not greater than, is not the same as saying, well, I can't support that you're greater than. My data doesn't support that. That's a little bit fuzzier. It's less strong. And that's what you have. You have not enough evidence to support your claim. So, step 5. Who's confused by step 5? There's only 2 parts to step 5 that you need to worry about. One is enough evidence, the part in blue, or not enough evidence. That depends entirely upon step 4. If you reject H naught, if you're in the shaded area, then you have enough evidence. If you're not in the shaded area, you do not have enough evidence. Step 4. That's all about step 4. This part here, so that's the first thing you can change. You either have enough evidence or don't have enough evidence. The other thing that changes is where they use the word reject or support. You always use reject if your claim is H naught. You always use the word support if your claim is H1. So that goes back to the very first step. Which one's your claim? If H naught's your claim, if your claim is or equals, then your claim is H naught, and you're always going to use the word reject here. If your claim is differs or greater than or less than, then you're going to use, then H1's your claim, and you're going to use the word support always. And then the rest of it is that, and then state what your claim is. Stating the claim in just repeating the words that they said in the claim. That's worth 1 point. If you don't do that, that's 1 point that you're going to lose off your exam. So it's really easy to pick up that point by writing that. Okay. So you might say, well, I'm confused about this reject support. How to remember that? Remember I had that mnemonic? QRS, yep. So what comes first, H naught or H1? H naught. What comes first, R or S? R. So H naught, reject. Use the word reject. Why? Because if H naught is your claim, then rejecting H naught rejects your claim. They go hand in hand. If H naught is your claim, then not rejecting H naught fails to reject. Failing to reject H naught fails to reject your claim. If H1 is your claim, then rejecting H naught supports your claim. And failing to reject H naught fails to support your claim. So that's why you use those words. But you need to remember what comes last, H1, what comes last, support, S, support. So those, you can use that to help you remember that if you need to. All right, so do you guys need just 2 more minutes to finish up quiz problem 1? Okay, take 2 minutes, do it. Who's done with it? Carla, you've written on the board already, right? Huh? You were on the board last night? Yeah.
Or fail. Either way. Fail to reject H naught.
Is anybody going to freak out if someone does on the board incorrectly? If someone does it on the board, if you do it on the board and you're wrong, is anybody gonna be upset about that? I mean, well, we'll fix it, right? I mean, it's like, we're all gonna just do it, so just do it on the board and we'll sort it out as we go, don't worry about it. Because you all could be in the same spot. And
You have to do it in the, yeah, it's the SX.
I was studying this weekend. I was looking at I start laughing.
You get it?
You're asleep. Okay, come on, wake up. I know, I feel you. You're being there. Read it, you can do it. That's what they do. In the military. Read it? Okay. So step one. I want to see you play. The first thing you have to do is just use the just always use the U equals whatever. And then you start to say you do the same. Equals what? There you go. Now, 8, no, like, column.
Okay, so how do you put your data into the calculator? Stat edit is how you put your data into your calculator.
Okay, keep going. So now do that.